Hello students, hopefully you will be good. Today I'm going to perform one sample Z testing in the Minitab software. Minitab is a statistical software. So what is Z test? Basically Z test is a statistical test which is performed either when our data size or sample size is greater than 30 or when we know the standard deviation or variance of the population. So these are the two conditions, and in the one sample only a single sample has been available to us, and we are going to compare the statistics of one sample with some hypothesized mean. Okay, so this test is related to the mean. I'm going to select my example from the book of Design of Experiments by Montgomery. Let's go to that book. So I have this question that the diameter of the steel shafts are produced or manufactured by a manufacturing process. Basically, the steel shafts are produced on a lathe machine, and they should have the steel shafts should have a mean diameter of 0.255 inches. So this is our hypothesized mean which we want to attain or achieve. The mean diameter is known to have a standard deviation of 0.001 inch. So the diameter, the standard deviation which we know, it means that based upon previous data we know the standard deviation. So based the previous data we can assume that the whole of the previous data, it will serve as a population for the calculation of standard deviation for a specific machine on which the steel shafts are going to be manufactured. So during the manufacturing process, a random sample of 10 shafts have been collected, and the diameter and the diameter of each and every shaft was measured, and then we take the average. We got the average of 0.2545. So this is the value we have obtained, this value from the sample. So it will be served as a mean value. We can represent this value as x bar or y bar. The hypothesized mean, we represent this value of 0.255 by mu naught. This is over standard deviation 0.001 represented by sigma, and this is small n, that is 10 shaft. Now this is basically a summarized data. We haven't any actual values of the data, and we are going to the Minitab for input the data in the Minitab and for doing the further analysis. So in the Minitab, I will go to stat, then I select on basic statistics. We are going to test one sample, Z test. The window has been opened. Now we have to select any of the two options, that whether the data has been given in the column, means raw data has been given. So no, we have summarized data. I click on this selected sample size from the question. It is clear to you that the sample size is of 10. Sample mean, this is of 0.2545. So I write it as 0.2545. Known standard deviation, that is 0.001. This is known as 0. Okay. So perform hypothesis test. Yes, we are going to perform the hypothesis. The hypothesis mean is 0.255. It is clear from the question, 0.255. Okay. So none, it should have a mean. So it means that equality sign will be involved here. Why equality? Because when we go towards the option, there are three kinds of the alternative hypothesis, that whether the mean of the sample is less than hypothesized mean, not equal to hypothesis mean, and greater than it. So from the question statement, it is saying that should have a mean. It means the equality will be in the null hypothesis, and unequal and not equal to, it will be in the alternate hypothesis or research hypothesis. We'll click OK. Then we click OK. We got this value. We have a sample of 10 sample size, 10 observation, mean this standard error. Based upon this value, we have got confidence intervals. Null hypothesis that mu is equal to 0.255, alternate hypothesis or research hypothesis, mu is not equal to 0.255. We got a z value minus 15.81, and the associated p value is too much less. So we can make our decision either in order to reject the null hypothesis or fail to reject the null hypothesis based upon two things. The one is p value, as the p value is too much less as compared to the cutoff value which I have taken in this question is 0.05. The second method is upon the z value. So we will have to check the criteria for the z. Based upon the z, how we can reject this hypothesis. So I'm going towards the criteria. So this is the criteria. These are the criteria, different type of hypothesis, one sample and two sample hypothesis for the z test. So we check this. This is a special. This is the case we are dealing with, that mu is equal to hypothesis mean and mu is not equal to hypothesis mean. So in this case, how we will, this is the rejection criteria, that if the modulus of the z naught or test statistic value is greater than z alpha by 2, then we will reject our null hypothesis. So now we will check that whether this criteria has been satisfied or not. So I am going back again to the Minitab in order to check the value of the z naught and z alpha by 2 value have been will be checked from the z distribution table. So for one sample z-test, we can check the cutoff values from this information, that if we take the level of significance alpha is equal to 0.05 and our test is one tail, can be one tail or two tail. So the case we are going to solve is a two tail test. So if we assume a normal distribution, towards the right hand side we have a cutoff value of 1.96, and towards the left side we have a cutoff value of minus 1.96. If you are interested in again how these cutoff values has been obtained, I will make a separate video of that. Please comment on that on this requirement. So these are the cutoff values. These are z alpha by 2. Okay, now I'm going to Minitab in order to compare the value of test statistic and the cutoff value. So I got z naught is equal to minus 15.81, but this minus 15.81, it will become positive. I have told you in this criteria table that z naught we will get modulus of that if this value is greater than z alpha by 2. Now z alpha by 2 for alpha is equal to 0.05, it will be 1.96. So we'll check that what our data says. So 15.81 is obviously greater than 1.96, and it's too much greater than, is a very huge difference between that. 15.81 is a magnificently greater than 1.96. So we reject our null hypothesis. So what we have concluded from our question, that what this statistic says. So this was the question, and we assumed that over shaft producing have a mean diameter of 0.255. This was a null hypothesis, but based upon these results that are obtained from this test, we now making the claim that we reject our null hypothesis, and based upon the data over shaft producing, the shaft we are going to produce from this process, their mean diameter is not equal to 0.255. I hope you like this video, and if you have any question, please comments on this video, and please subscribe my channel. Thanks a lot for watching this video. Bye bye.